Hello friends, I welcome you in lecture number 4 on curve fitting. Up to lecture number 3, we have seen how to fit a second degree polynomial of the form y equal to a plus bx plus cx square to the given data. And in the topic of regression, we have seen how to fit a straight line to the given data. So far we have studied this type of fitting of this type of curves, fitting of a straight line and fitting of second degree polynomial or fitting of a parabola. Now third type is fitting of power functions or exponential function. We are familiar with the power function. We know that if I write y equal to a times x raised to b, then this function is called power function, and if we write y equal to a times b raised to x, then this is called exponential function. So now onwards we are going to discuss how to fit power function to the given data and then how to fit an exponential function to the given data. Here if we consider b equal to e, then we have y equal to a times e raised to x. So this is natural exponential function and this is generalized exponential function. So sometimes they can ask you to fit a curve which is different from straight line and parabola, and they can ask you to fit a power function or exponential function also. So in this lecture we will see how to fit a power function to the given data, and in the next lecture we will discuss fitting of exponential function. So here suppose we want to fit a power function to the given data, then how to fit this type of power function. So method is easy. You have to just take logarithm on both sides of power function. Suppose we want to fit the power function y equal to a times x raised to b, then first step is take logarithm on both sides of equation 1. Now whenever we are talking about logarithm, we have to decide that logarithm to which base. So there is no restriction here. You can take logarithm to the base e, or you can take logarithm to the base 10 also. That is your choice. You can take logarithm of any base. So suppose we consider logarithm to the base e, then we have logarithm of y equal to log of a times x raised to b, and using the property of logarithm we know that log of product equal to addition of logs. Log of m into n can be written as log m plus log n. So here I consider m equal to a, n equal to x raised to b, and I rewrite this as log of a plus log of x raised to b, and this again we can write using the another property of logarithm. We know that log m to the power n is n times log m. So this I can rewrite as b times log x. So I obtain log y equal to log a plus b log x. Now suppose I denote log of y by capital Y, log of small a by capital A, and log of small x by capital X, then I obtain this expression capital Y equal to capital A plus small b times x, where y is log of y, capital A is log of a, and capital X is log x. Now what is this expression 2? So it is an equation of a line. This is the equation of a line of y on variable capital X, and whenever we want to find out the line of y on another variable x, then we use the method of least squares. We find out the corresponding normal equations, and then solving those normal equations we decide values of these constants capital A and b. We have seen if we want to fit a straight line y equal to a plus bx, then we can find out these constants a and b using the normal equations. So what we have done here, we want to fit the power function y equal to a times x raised to b to the given data, and applying logarithm of any base to the given equation of power function, we are converting our curve from power function to the straight line. So our curve is now, we will concentrate on this part, equation number 2. We want to find out line of capital Y on capital X, and we know how to find out these constants capital A and small b. So once we are able to decide this capital A and small b, we can obtain this small a simply by reversing this. We know that if capital A equal to log a to the base e, then we can write a equal to e to the power a. Suppose we have taken logarithm to the base 10, then a will be equal to 10 to the power a. So whatever base of the logarithm is taken, we have to take capital A into the power of that base. Again, I emphasize that there is no restriction on the base of logarithm. If you wish, you can use natural logarithm which is having base e. If you wish, you can use logarithm to the base 10 also. So there is no restriction for taking logarithm of the given equation, and there is no restriction on the base of the logarithm. But whatever base you are taking, you remember that you have taken logarithm to this base, so that when you want to find out this small a, you can consider appropriate base. If we have taken natural base, we will consider small a equal to e to the power capital A. If we have taken base 10, then small a will be equal to 10 to the power a. And here also we can use any base for the given logarithm. So now equation 2 is the line of regression of y on x, in which capital A and b are unknown quantities, and that we can determine using the method of least squares, which we have discussed earlier. And once we are able to decide capital A and b, we can decide small a using this expression, and once we find out small a and small b, we can put their values in the original equation, and we can decide the required power function which is of best fit to the given data. So let's understand this method with the help of one example. This example was asked in GTU Summer 2021 exam. By the method of least squares, fit a curve of the form y equal to a times x raised to b to the following data. Values of x and y are given. So first we have to write down how we are transforming our curve from power function to the straight line. So here I have written, we are asked to fit a curve y equal to a times x raised to b. Now taking natural log on both sides. Here I am taking logarithm to the base e, that is natural logarithm, so that we can denote by ln y also. Taking natural log on both sides, we have ln y equal to ln of a times x raised to b, and using the property of logarithm, this I can rewrite as ln a plus ln x raised to b. This again I can rewrite as b into ln x, and now I consider this ln y equal to capital Y, ln a equal to capital A, and ln x equal to capital X. And we see that we have converted our equation from power function to the straight line, where capital Y is ln of small y, capital A is ln of small a, and capital X is ln of small x. And here base is natural base, so whenever we are interested in the value of small a, that will be equal to e to the power capital A, and value of capital A and small b will be obtained by solving the normal equations corresponding to this line of capital Y on X. So now I have written normal equations. Sigma Y equal to n times A plus B times sigma X. Second normal equation can be written by multiplying this equation by x and then taking logarithm on both sides. If we multiply this equation by capital X, we have a into capital X plus b into x square, and now we take summation on both sides and we have sigma xy equal to a times sigma x plus b times sigma x square. To solve these normal equations for capital A and small b, we have to first decide all these quantities. So we have to prepare the table. We will require capital X and capital Y, that is we have to take natural logarithms of given values of x and y. Then we will require x into y and x square. So I have prepared that table accordingly here. In the first two columns we write down the given values of small x and small y. This is the column for natural logarithm of x. So I have taken natural logarithm of each of these x values and that I have written in this column. This column is for natural logarithm of small y. So that I have written here. Then I have taken square of each x values using scientific calculator up to 4 decimal places. And then I have prepared the column for the product of capital X and capital Y. So I have used this logarithm to the base e. If you wish, you can do your calculations using another base, say 10, and you can compare your answer with my answer. You will get the same answer up to certain decimal places. Due to round off, you can have some differences, but up to some decimal places answers will be same and answers will be given correct either you are using natural base or base to the or base 10. So that is your choice which base you want to select for your calculations, but there will be similar answers for any base, so that you have to keep in mind. Some books are using natural base, some books are using base 10. So no problem, either you want to use natural logarithm or logarithm to the base 10, your answers will be same, final answer. So now I have all these values. From the table I can write sigma x is 4.7874, this is sigma y, this is sigma x square, and this is sigma xy, that I have written here. And I require all these values for writing normal equations for capital A and small b. So I have substituted these values sigma y, sigma xy, sigma x, sigma x square from this table into these normal equations, and I obtain these two normal equations. Now these are linear equations in two unknowns, capital A and small b. So if you wish, you can apply any method or you can use Cramer's rule. I am comfortable with Cramer's rule, so I am using Cramer's rule to solve this system. For Cramer's rule, first we have to decide the determinant of coefficients of given unknowns, capital A and small b. So we first find out determinant of these coefficients, that we denote by capital D. So first column corresponds to determinant corresponds to coefficients of capital A, and second column corresponds to coefficients of this B, and this turns out to be 1.8780. We know how to find out this value, 4 into this minus in the bracket this into this. Now we find out determinant corresponding to this unknown capital A. So for that determinant we replace this column which corresponds to this unknown A. This column is replaced by these constants. So we replace this column by these constants and we obtain value of D suffix A. Similarly, we find out another determinant corresponding to small b. In that case, to write down this determinant, we replace this column corresponding to small b by this column. So that I have calculated here. D suffix a turns out to be 3.7534. D suffix b turns out to be 3.6251. Now by Cramer's rule, capital A is value of determinant corresponding to a divided by this. So that I find as 1.9986. Similarly, small b is this determinant d suffix b divided by capital D, that turns out to be 1.9303. Now once we have value of capital A, we know that capital A is ln A. So therefore small a equal to e to the power a, and we have obtained value of capital A, so that we substitute here, and we find that small a turns out to be 7.3787, and we are already having value of small b, and we are interested in this y equal to a into x raised to b. We are interested in values of small a and small b, so that we substitute here, and we find that this is the required curve for the given data. So we have converted our curve y equal to a into x raised to b by taking logarithm. We are converting this into the line of regression, and solving normal equations, we find that this is the required answer. This is the curve of best fit to the given data. Now suppose you want to use another logarithm to the base 10. So I have done my calculations using logarithm to the base 10 also, and I find that my answer is 7.3756 x to the power 1.9311. This is the answer using logarithm to the base 10, and this is the answer using logarithm to the base e. And you can compare this answer. If you compare these values, here I have 7.37. If I round off up to 2 decimal places, then this is 7.38 x raised to 1.93, and if you round off this up to 2 decimal places, here also you have 7.38 x to the power 1.93. So our answers are exactly equal up to 2 decimal places. So I have done my calculations using logarithm to the base e as well as using logarithm to the base 10. You can do these calculations by taking logarithm to the base 10, and you will obtain this answer, and you can compare both the answers. They are nearly equivalent. So there is no restriction on the logarithm of on the base of the logarithm which we are applying. That is our choice. Either we want to use natural logarithm or base 10, or we can use any other base also, alpha, which is different from e and 10. So that is our choice. So in this lecture we have discussed how to fit a curve of the form y equal to a times x raised to b, where a into x raised to b is the power function, and we can see this is very easy. We just have to take logarithm, and using the properties of logarithm we are transforming our curve into the straight line, and we know how to find out equation of straight line solving normal equations. So our aim in this lecture was to decide these coefficients, these constants a and b, and that we have decided successfully by taking logarithm to the base e, that is natural logarithm. And if you wish, you can do your calculations using logarithm to the base 10, and you can note down this answer. Your answer will be this one, and you can compare both the answers are nearly equal. So this is all about this session. In the next session we will discuss how to fit an exponential curve, that is y equal to a times b raised to x, or if we take b equal to e, y equal to a times e raised to x. So I stop here. Thanks for